All right, well, let's get started again. So aggregate functions are the next thing we're going to talk about. And they're another thing that can tend to confuse people the first few times you see them, but they're really, really useful. So it's worth thinking through a little bit. So we'll start with the simplest one, and that's select count star. So this kind of does what you'd expect. It just counts, how many rows came back. The star is a special value in this case, in that it specifically means rows. We also can do a count of a specific column, and it'll count the number of non-null values. We'll talk about what that means a little bit later. The next one we can do is sum. So that adds things together. I mean, fairly self-explanatory here. And the way these functions work, you'll notice that if we were instead to do select star, we get 4 rows. But when we do this, we get 1 row. So the way an aggregate function works is every row or every value gets fed into it, but it reduces or it aggregates those values down to a smaller number. In this case, every row gets fed in, 1 row comes back. We can also average. And there's a handful of other ones that we use occasionally. There's max and min. There is, like, we can do this here. We'll see what was our longest call, what was our shortest call. And there's a handful of more mathematically oriented ones, like you can ask it to give a standard deviation, things like that. But these are the common ones you'll use. There's maybe a dozen total that are used on a fairly regular basis built in. But all of these here that we've been doing, we're saying aggregate everything in the whole table. But lots of times we need to group things together. So group by is the way that we define what buckets or what groups all these things are going to go in. And we're going to run this one, and then we'll talk about this a little more and try and visualize this. So we selected contact ID and count number of rows from calls group by contact ID. So here's what this actually does. It's good to get a mental model of how the database is actually working, or rather, at least the rules it obeys. So when we run this select statement internally, we can visualize it as we're starting from here. We have these 4 rows. This first row gets processed, and what happens? It goes to the group by, and it says, okay, contact ID 1. Do I have a bucket or a group already existing for contact ID 1? I don't. Okay, I'm going to create a new group for contact ID 1. So I'm going to try and visualize this here. So we're going to have group, and we'll say count is over here. So when we start out, we're empty. This first row comes in. The database looks at the list of groups, and it says, do I have a group for contact ID 1? I do not. So the first thing I'm going to do is create the group. Then I'm going to run this count function. So, okay, we're going to pass this row into count. Well, what does count do? It increments the number. So we're going to go over here, and we're going to mark that as 1. Okay. Next row. We get to this next row, and it says, do we have a group for contact ID 2? Because contact ID, again, is what we're grouping by. We don't. Okay, let me create a group for contact ID 2. And we're going to feed this row into this aggregate function. all it does is increment the count, which obviously starts at 0. So, okay, now we have a count of 1. We go to the next row, contact ID 2. Do I have a group for contact ID 2? I already do. Okay, so on that group, let's increment the number. We go to row 3, or row 4 rather, and contact ID 2. Do I have a group for that? Yes, I do. Let's feed it into the count function, and we end up with this as what comes out at the end.
Is there a reason it comes out sorted from high to low?
Yeah, is there a reason? It is undefined, the order. If we go back to where we talked about having an order by clause, since we did not include an order by clause, the order is undefined. Now, is there a reason? Well, I mean, if you dug down far enough into the source code, there would be some reason somewhere. It is a deterministic process. It's not like something random is happening somewhere. But that process is based on things that you don't know or need to know or understand or whatever. So it's formally defined as the order is undefined.
Jack, those two terms you use there, deterministic and defined, I think are maybe worth breaking down a little bit further.
Sure.
Yeah, my definition of those two terms, and maybe we can arrive at one together. Like, if something is not deterministic, that means that the order isn't like predictable, I think is maybe how I would describe it. Whereas undefined means you're not explicitly telling it what the order should be.
Well, I mean, that is how we could look at it from the point of view of the person typing the things in. But I guess from the more like mathematical point of view, the non-deterministic means that, or rather the fact that it is deterministic. That is, if we knew the entire state of the computer, we knew where every byte on the hard drive was, we knew what every byte in RAM was, we knew what the state of the CPU registers are, we knew the state of every single thing, and we run this query. It is deterministic. All those things are the inputs into it. It will happen the same way every time. But it's undefined in the sense that the SQL standard does not guarantee any particular order. Maybe that's a better way of putting it. And in fact, they specifically disclaim, saying it's going to be anything in particular.
I think a practical takeaway for that would basically be like, if the order matters, you should say what you want the order to be.
Yeah, that is what all this boils down to. If you want order, you have to specify it, because it may always work for you, and then you go to somebody else's computer and they're on a different operating system and it doesn't work. Or you put it in production and the database has more records there, so something different happens. Or in production, 2 people are using it at once. But yeah, order by just is required if you want the order. So let's run this thing here. And it gives us this scary looking error message. So calls.callStart must appear in the group by clause or be used in an aggregate function. So it tells us like what the problem is. It doesn't really explain why that's a problem though. It says it is, but it doesn't say why. So let's talk about this. Anybody have any idea, why doesn't it let us get the call start in here as well?
Would it be because call start, the amount of contact IDs in call start might be a different number than itself?
Well, I'm not sure if I totally understand what you're saying, but what I do understand, I think you might be right. What we're going for here is when we group by, we get this number of rows back, and we started with this number of rows. So for contact ID 1, I would say we could use this as call start, right? But what about for contact ID 2? We got 3 choices. Which one should we use? There's really no good answer. You know, the first one, the last one, well, the first one or the last one by which order? The biggest one, the smallest one, you know, we haven't told it enough information. You know, I guess another way of saying it is, you know, we're asking the SQL database questions. And we have given it a vague question, and it needs a precise question or it can't give us the answer. So because there's no way to answer this question properly, it says, you can't ask that question. Incidentally, this is an example of the difference between like Postgres and MySQL. As far as I know, this difference still exists. They might have fixed this at some point, perhaps, but MySQL would work with this query. It would just give you one of those 3. And, you know, I guess you hope you got the right one. Okay, so we talked about why this doesn't work because, you know, we got 3 options here and we only need one of them and we didn't tell it how to distinguish between them. For example, if we did say we want the latest one, you know, we could have said this. This would work now because 3 things come in, 1 thing comes out. So another thing that we can look at here, this is, again, fairly self-explanatory, I think, but we can have multiple aggregate functions in the same query. So we can say, you know, how many of them were there? What was the sum? What was the average? We can ask all those questions at once. And now to get even more complicated, we can say, how about we join stuff and we do aggregates all at once? Now, this is probably a good point if you're following along and actually like typing stuff out, to take a step back and realize that typing all these commands in here is kind of annoying. And there is a better way of doing this. So if you open a new file and put a SQL query in it, you save that file in your current directory. I'll just call it like t.sql. I usually call it t just for temporary. \I is how you read a file in and execute it. Now, if let's say I made a typo, I can use my text editor here and I can change whatever I need to change, just resave the file and rerun it. And that's a lot easier than trying to edit, you know, these huge queries, you know, just directly in PSQL. And it's really important when we get to huge queries. You know, this is not huge. You know, I work on stuff that's, you know, it's not all that uncommon to have dozens of lines in a single query, and it easily can go to hundreds sometimes. So let's look at this query though. What did we do? So this is a combination. If we want to look at what actually happened here, this is a combination of the 2 things we talked about before. How did the join work and how did the group by work? So to see where we start with, we're going to go back to this query and we end up with this. So this is the source that all our group by and aggregating happens with, that table that's those 2 things joined together. And if we really wanted to, we could go all the way back to the cross join, and then from the cross join, it gets filtered down to these 4 rows. Then the group by says we're going to group by 2 different things. we're going to group by the ID of the contact, and we're going to group by the name. Because if you recall, it whined whenever we had a column that either wasn't part of the group by or was not an aggregate function. So we're going to include both of these. There's a few shortcuts you can use to type less here, but for simplicity's sake, we'll just do it the long way. So the same thing happens with these 4 rows. We get to the first row and it says group by contact ID, which is right here, and group by name, which is right here. Puts those into a bucket, does the count. Sum takes this duration, adds it to its accumulator. Average takes this, puts it into its accumulator. We go through this row, creates a new bucket. Each one of those, the aggregate function has its own accumulator, does the thing. And when it's finally done, the 2 rows come out. So, like I said, joins tend to be confusing. Grouping and aggregates tend to be confusing. Any questions here?
The reason you only got 4 rows is because there's only 4 calls and they're only assigned to 2 people, correct?
Yes. So when we, there originally was that 76 when we cross-joined them, but only 4 of those rows, this is true. And those correspond to, we have 4 calls and each call, obviously belongs to one contact.
Okay, thank you.
Mm-hmm. So there's one kind of problem with what we got going on here. We want to say, how many times did I talk to these people? Well, we've got 19 friends or 20 friends in our address book, and only 2 people came out. What if we actually wanted to see, 0 for all the other people? And that's where what is called a left join comes in. Now, we talked about this, somebody asked a question and they mentioned about, left joins and outer joins and inner joins. So a left join also is sometimes written or spoken of as a left outer join. But just like inner, the outer word can typically be left off. So it's typically just written as left join. And this join type is a little different. We're going to examine this. We'll start by looking at just what does it look like just when we do the join. So what this does is left join means for every row on the left, make sure every row on the left shows up. Now, if there's a row on the right that matches it, great. But if there's not a row on the right, fill in everything on the right with nulls and give me the row anyway. So we can see here we have our matches where we do have a call, but for all the contacts that we never called, we just get nulls. Now with this in mind, if we go back here and we add in the group by stuff that we had before, now we should actually get a row for Belia and Nina and Chantel and Kari and John, all these people. We should get rows for them because they're in the original data. You can, the reason I keep going back over, how does this go from the cross join down to the inner join and all these things, is you kind of got to get a mental model of this pipeline that happens where, we get all these potential rows, then we filter it down here, then we group them together, then we sort them, then we limit them. And it's extremely valuable to have that mental model. So we're going to be feeding these 21 rows into this group by. Now let's see what happens. Save this. Okay. So we still have our 1 call to Miranda and our 3 calls to Lydia. Does anybody see any problems with this?
The count is 1 even though they didn't have anything.
Exactly. So the problem we're having here is we're saying count star. Count star means count how many rows get fed into this thing. And the problem is 1 row was fed into it for every one of these. What we really want is we want to know how many of these were not null. This whole thing here, any one of these columns. So what we would do is we would say, how about calls.id? Now the count function increments, it counts every non-null value. So if we do this, now we get zeros. And again, I know this stuff, it gets kind of confusing the first half dozen times you see it. So definitely, if you have questions, definitely speak up.
So I think I might have missed something because in my sum and averages, I have just nothing unless there is a call to go in there. I'm seeing you, yeah.
Okay, so actually, I'm guessing probably everybody looks that way. And let's talk about that a little bit. This is a good time to talk about that PSQL RC file. So remember when we talked about that, like mine keeps showing the time, and that was something that it doesn't do for you all right off the bat? This is why. These are all commands that you can run in PSQL, and they customize it for you. So like this one here, if I'm running a script and an error happens, I want it to stop. I don't want it to just keep going. This turns on the timing. This says when a null comes around, show that mathematical empty set character instead of just show nothing. So if you wanted that to happen, you could say, you could type, \pset space null, and then you could put anything you want there. And whenever that magic value null shows up, it would display that character. So I think I don't remember if it was you, Jake. I think it was Jake or one of my other friends at Hashrocket ended up using the emoji for the skull for a while as kind of a fun, this thing is dead. There's nothing there. But you can put whatever you want there. And the reason we customize this is otherwise you can't tell the difference between an empty string and a null.
So I also keep having to turn back if I want to see the timing. I've noticed that it just keeps turning off randomly and I have to keep turning it back on, by \timing. Would this, if I just did all that, prevent that? Or is that something that's going to keep happening?
So when you say it turns off, I'm guessing what you mean is like when you leave PSQL and you come back later?
I'm not even sure if it's just that. I think so.
Okay, because it should stay on until you specifically turn it off. But by putting it here, it automatically runs when you start, the PSQL program.
So it's not like doing it every time I quit. It's every time that I actually exit PSQL, and then I have to bring it up again.
Yeah, it does not remember any of those settings. The way essentially you save the settings is you put it in this file. And essentially what this file does is it's as if you typed all these things as soon as you start PSQL. So I guess just to quickly explain what the rest of these are. The reason my background looked blue and had that kind of little different appearance is I have a special pager installed. You've probably run into stuff where you're using less, in the command line, and various tools will use your default pager. So I told it to use a different pager. You can tell it what type of lines to use when it's drawing these type things here, the table lines. You can tell it what lines to use. And you can also, if you really want to dig in and get to some real arcane stuff, you can tell it to configure your prompt. So you may have noticed that when I was let's see, what is it? Lesson? Is that where it is? Nope, that's not where it was. Let's see here. There we go. When I'm in PSQL, it shows a little bit different over here. That's because of this giant bit of line noise there. You know, it says it to change the color, and then some of these things here, like tell it, you know, show my username, then show, you know, what database server I'm connected to, then what port, you know, various things like that. You don't really need to mess with it, but that's why it's showing different things.
Thank you.
Mm-hmm. Okay, so let's talk about what null is. We've kind of briefly intersected it before, but it starts to get a little more important here, where we were talking about, you know, how are these things counted or not. And for null, let me see here. I usually am standing in front of class with people in front of me, so I have like some props and stuff here. I guess we'll try and just do this audibly. If somebody walks up to you and they hold both their hands out with their fists closed, and they say, I have some change in each hand. You know, I have a quarter, a dime, a penny, a nickel, whatever. And they have their fists closed though. And they ask you, is there a quarter in my left hand? Is there any way for you to tell outside of prying their fingers open? No, not really. The only answer to that question is, I don't know whether a quarter is in your hand. Now, what if let's say they have their hand open and they have a quarter in the palm of their hand. So then you ask the question, is what's in their hand equal to a quarter? Well, you can say, yes, that is true. Or you can say, is what they have in their hand a dime? And you can say, no, that's false. But if their fist is closed, you don't know what they're holding on to. So any question you ask about what is in their hand, the only answer you can give is, I don't know. Now, here's what's the problem with null. We talked about before that null can mean empty, and it can. The problem is null serves the dual purpose of also meaning, I don't know what it is. Here's where that's kind of can trick us. So if we say, does 1 equal 1? We're going to get back true. Does 1 equal 2? We get back false. So far, no big surprises, right? Does 1 equal null? We get back null. Null kind of corrupts, in a sense, anything it touches, or it infects anything it touches. So we have to be kind of careful with it. Now, so far, this might be slightly surprising. I mean, when I see does 1 equal null, I would kind of expect false to come back. But okay, null is a falsy value. You know, most places, if null comes back, it's kind of treated as false. So it's like, okay. How about this? This kind of looks true to me, but we get back null. And here's the analogy for that. We talked about asking, like, what is in someone's hand when they have their fist closed? Well, okay, somebody comes up to you and they have something in each hand, but their fist is closed. So it's closed. What does that mean? I don't know. So I don't know what is in their left hand. I don't know what is in their right hand. Is what is in their left and right hands equal? The only thing we can say is I don't know. That confusion between I don't know and empty is also part of the reason that Jake mentioned at the beginning of the day that we try to set things to not null as much as possible, because null just tends to confuse things. So we avoid it as much as we can. So any questions, any thoughts on null? Okay. Let's talk about a couple of functions here that are pretty nice. So coalesce is one way we can deal with this. So if we go back to this statement we have here, you notice that we just get the null value for how long did we talk with them? Well, we didn't talk with them for null amount of time. We talked with them for 0 amount of time. So it makes sense to actually have that be a 0. What coalesce does is it's a variadic function, which means it takes any number of arguments. And what it does is it returns the first argument that is not null. So if we were to say select coalesce null 1, 2, 3 null, it's going to return 1. And if we were to say, 2, 3 null, it's going to return 2. So first thing that's not null is the result. Well, we can use that in our aggregate functions. We can say, give me the sum of call duration, or if that's null, give me back just the 0 amount of time. Oh. And now we don't have nulls there anymore. We actually just have zeros. All right, so that's the finish of our first introductory lesson. So it's a good time if we have any questions for any of the stuff we've covered in the lessons so far. Okay, well, let's start with lesson 2 then.
I thought of a question.
Okay.
It's more kind of for curiosity, but I haven't seen any loops so far. There are loops though going on inside, right? I mean, how does it go through all the info?
Yeah, that's a good point.
I mean, I don't know.
Internally sorry?
Oh, I'm asking, I'm not saying, I don't know.
Oh, no. Well, you're right on both accounts. We are not writing any loops, but internally, the database server is using loops. That's actually part of the convenience, I guess you'd say, of SQL. We're asking questions at a much higher level than actually having to write. Think about, like, if you've done enough programming and you think about how would I do a join in Python or whatever imperative programming language, you'd probably think, well, I'd need a loop for the left side, and then I need an inner loop for the right side. And for every iteration of that nested loop, I have to say, is the left thing equal to the right thing? And if it is, append it to my accumulated array. And then finally, when I'm done, print out all the accumulated rows. That would be a lot more work than just telling the computer, hey, join these two things together based on this criteria. And it does all that work internally for us.
Jack, does that answer, like, hint at like the difference between like an declarative and imperative programming language, would you say?
Yeah, definitely.
it's a distinction that I'm always like having to Google because I don't use it a lot, but SQL is considered a declarative programming language, and other languages are like Ruby or Python are considered imperative programming languages. So declarative is you say what you want, but you don't specify the control flow of how it is accomplished. So like with SQL, you just say, give me this thing. And it's the nature of the language is that it knows how to do it in the way that it thinks is the best. Whereas in a language like Ruby or Python, you say, do this thing. Go through this loop and print out this thing, print out this statement each time. And that's how you get your data. So it's like two different approaches to programming languages is how I would describe it.
Yeah. And in fact, if we wanted to see some of what it's actually doing internally, there's a command, you can prefix a select statement with explain, and it asks the database, tell me what you're actually doing. Now, this is extremely difficult to read, but you kind of read it from the inside out. We can see that it sequentially scans the contacts table, and it sequentially scans the calls table, and it uses these hash condition things, the joins. That's how it joins together. It groups by this thing. It does an aggregate. This stuff is really arcane, but in a lot of these, whenever you see like sequential scan, well, it's looping over everything in the entire table, would be another way of reading that. And depending on the type of join you have, oftentimes it will actually say like such and such loop or something like that. Okay, we are going to move next to the time clock directory. So we're going to quit our PSQL thing. We are going to use the cd command to change directory, and we're going to go to time clock.
Would you recommend to drop the phone book database now or keep it?
It's up to you. We're not going to use it anymore, but our time clock database will be named something different. So,
Okay.
Doesn't matter.
Okay.
And we're going to start with lesson.sql here, just like we did before. And we are going to run through this fairly quickly. Then we're going to take a break, and we're going to do a exercise with that's more focused on querying. And then we're going to do the data modeling thing as our last thing. So I'm going to run through this pretty quickly. We're going to kind of abbreviate over most of the exercises. And then we'll have a little bit of time for talk at the end, and then we're going to take a quick break. So to start with here, we're going to, create DB, and we're going to call this time clock. And oh boy, it looks like I already have one of those. And then we'll run PSQL with tell it which database we want to connect to. So first thing we're going to do, obviously based on the name, we're just going to build the data structure for like a really simple time clock. So first thing we might want here is we need a list of employees. In Postgres, varchar is essentially an alias for text. Varchar standing for like character varying, if you see it written out longhand. So first name, last name, hire date, we'll just create this table. We are going to insert a couple employee records. And we'll go through these exercises, a few of them together here, because we only got about 15 minutes for this one. So newest employee, anybody want to speak up and say like what would be our general approach? We don't need the syntax, but what would be our general approach for how we find this newest employee?
You can get the employees' names and then the date that they were hired, and then sort it by descending, which should give you the latest date.
Yeah, exactly. So we can do select star from employees, order by hire date descending,
And you can also
limit 1 to just get the one we care about. And I misspelled hire date there. And there we go. That's our newest employee. We can do the same thing, just make it ascending to get the oldest employee. If we were curious how long each person has been employed, there's actually a really cool Postgres function called age. And what that does is it gives you from the now until that time. How old is it? And it tells us exactly how long each of these people has been employed. If we wanted to find out their average tenure, we could wrap that entire expression in the average function. I guess we need a group there. Or actually, we can't have the star because of group by. See, Postgres is keeping me from making mistakes here. So there's a couple of interesting questions, and this will start to give you a preview of what we'll talk about in the data modeling segment. But it's interesting, like, how do we represent various bits of data? Like in this case, how do we represent the period of time an employee was working? Or how do we represent it when the employee clocked in but is not yet clocked out? Or what if they forgot to clock out? And furthermore, like, what do we even call this concept? You know, is it a work period? Is it a shift? You know, hours worked, time clocked entries. Naming is something that you'll find when you get into the industry more, people tend to stress over a lot, because the name for a concept really is like the handle that your brain holds onto it with. And it kind of shapes the entire way you think about it. If something has the wrong name, you're going to think about it the wrong way. So we're going to create a new table here of worked shifts. That is not a very elegant wording there, but it is very specific as to what it is, so we went with it. Employee ID, we're using that references here, so we're saying there is a foreign key relationship. This is a new one here. TSTZ range is for timestamp with timestamp range. Postgres has the idea of ranges. And I don't know if you're familiar with it, like in the mathematical sense of, you know, if you ever seen stuff like that in math for the notation of a range. Postgres actually has ranges. And you can ask it questions like, it's in 4 range. Is 5 within this range? Yes. Is 15? No. And you'll notice like the square and parentheses thing denoting, you know, inclusive and exclusive range ends, you know, respectively. So 1 is part of the range, 10 is not part of the range.
I have a quick question.
Sure.
So you had said timestamp with timestamp range. Did you mean timestamp with time zone range, or did you mean timestamp range?
Yeah, if I said with, yeah, it's with time zone. So indexes is another thing here, and we're really just scratching the surface of this stuff. We're kind of giving a survey of a bunch of things here, but think about a physical paper book. And this book is 500 pages, and you want to look up, some particular topic. We'll say it's a book on SQL, and you wanted to find where they talk about primary keys, for example. Well, if it's 500 pages, one way to find that is to read all 500 pages until you find the words primary key. The other way to do it is to go into the back of the book and look at the index. Indexes in SQL databases work exactly the same way. It's a lot quicker to look something up in an index, and that tells you where to go to find it, instead of searching through all the data. So another general rule of thumb is foreign keys should almost always be indexed. So we're just going to tell it, create an index on this column. And Postgres is smart enough that depending on the sizes of the table, depending on what questions we're asking it, it will decide, do I look in this index and then that index? Do I look at table A, then table B? Do I just read all the data in memory? All that sort of stuff that you would decide by hand if you were writing this imperatively, like in a nested loop. Postgres will figure it out for you, and it'll decide, how do I actually read this stuff off the disk drive? Okay, we are going to insert our first WorkedShift row here. And let me explain a couple of things here. So like this thing here, this : int4 range. The : and a type name, that is how in Postgres you do a type conversion or a typecast. Excuse me. So we are telling it that string, convert that to an int4 range. Another thing we can do is there are like constructor functions. So this is another way of constructing a range. And this thing here where we have tstz range and then we have 2 timestamps, we are telling it construct the range from there. So we can say select star from worked shifts, and there we go. Now this is, again, this is just a quick survey to tell you you can do these type things. Postgres also has the ability to prevent ranges from overlapping. And again, the exact syntax of this is getting into intermediate or more advanced things, so we're not really concerned about the exact syntax here. It's really useful for you to know that you can do this. So we'll try and insert a record here, and it doesn't let us. This one here, there's multiple types of overlaps. What if it's an exact duplicate? What if it overlaps the beginning? What if it's the end? All these different things. You can imagine if you had to write if statements to try and catch all these different ways ranges could overlap, that would be kind of hard. But in Postgres, you don't have to. All of these are going to error out. Even something like this where the range is unbounded. So this is how you say they signed in at 6 and they never signed out. It'll still detect that type of stuff. Here we have this idea of an unbounded range. So they've signed in, they have not yet signed out. There's functions here for saying upper infinite is what this stands for. So it's like find all the people who are clocked in right now. Or rather find all the in progress shifts. We can even do things like, okay, how long was this shift? And we can see that first one we entered was 5 hours. The next one is null because, anything plus or minus null is null. This person hasn't signed out yet, so it doesn't really make sense for us to know how long the shift is. So there's a link to the documentation here for ranges. Ranges are just something really useful to know that it has, but we won't need to actually do anything much more with it today. So we've only got a couple minutes till our next break, so we're just going to run through this. There's some exercises here, and just like the other stuff, all the solutions are in the solutions file. So if you want to review this later, we're just going to look at this stuff real quick. So first we're going to get rid of all our existing shifts. Then this is another function that's kind of interesting, generate series. What this does is it basically builds a temporary table for us of however many rows. So with this thing here, we're saying from today's date, you're from 30 days before today, go all the way to today, 1 day at a time. That's pretty cool. So when we need to do ranges and you're like, okay, here's an example of where this would be useful. So let's say we had, we wanted to find out how many sales we had every day. Well, if we're a low volume business, there may be some days we did not have any sales at all. So we would use generate series to get the list of days. We would left join to our sales table, and then we would, group them together and use coalesce. So we have like, oh, there were 0 sales on this day. And here's that example of we could do this to get a record for each employee on each day. Yeah, I apologize. I know I'm going super fast here. The random function just gives us a random number. We have mathematical things like ceil. And now put all this together. And we now have a table of random shifts for all our employees. Every time we run this.
Ceil is ceiling for the opposite of floor?
Yes, exactly. Now, employees don't work every day, so that's where we'll use that random thing. We'll say 80, that little pop-up there is getting annoying. We'll say 80% of the time a shift occurs. So we're even going to get like a different number of rows each time. Now, again, for the details of this, don't really worry about this yet. But here's something else interesting. Remember we talked about there's multiple ways to insert? So the insert statement actually starts with this, but the next thing is a table expression or something that returns a row set. Maybe would be another way of saying that. So that can be one of those values lists, but it also could just be an entire select query. So we'll just say the result of all of this select, insert it. And it inserted 95 rows there. And now we can see like how long total have people worked. We could say how long has each person worked? In general, we just have a bunch of sample data there we can work with. And there was a handful of exercises that you might find interesting, at least look at the solutions. The other thing here is what if we wanted to filter after the group? So like this example here, what if we wanted to say, I only want to know about employees who have worked, we'll just change this and say at least 120 hours. Well, to do that, we need to use the having clause. Having is exact, it works basically exactly like where, only it happens later. So Having occurs after group by, where occurs before group by. So if we were to run this here, in fact, I'll change this to, how about 115 hours. And we were to run this, it would filter it so we only see our employees that have the most hours worked or over a certain limit. Okay, we've got some optional discussion here, but I guess it's good it's optional because we're going to take a quick 5-minute break. We'll come back 2:02